Hi there. Okay, so this is the GY561 frequency and power meter, and I have a problem with it, so I will show. So first let's make sure that the batteries that I'm inserting inside are new. I know that they are new, but we'll test them. So 1.54 volts, second battery 1.54 volts, they are all brand new, and the last battery 1.54 volts. Of course the rate is 1.5 volts because they are brand new, so the power is even a little higher, the voltage. And I'm inserting the batteries and let's see what happens. This is brand new, just received it. Now let's power it up. So you see first that it was power, and then now you can see garbage on the screen. Okay, so now I'm focusing on the LCD, so we will be able to see garbage, garbage, garbage. This is brand new, but pressing again you see some number and garbage. Powering off, powering on, it is starting to show something. Now it's okay. Sometimes it's okay, sometimes you get garbage. So let's try to find out what happened with it. Now again garbage. Of course this is non-usable, you can't use it like this. So now we will disassembly and check if we can fix it at all, or maybe we cannot. I don't know if this is an LCD connection or soldering, or maybe other thing, maybe microcontroller is bad. It can be anything. So it's really hard to say what is the problem. Sometimes it works, sometimes it is not working, sometimes it is not powering on. Oh, this is a bad sign. And as you can see, garbage, marks, numbers. Looks more like, I don't know. So no other way than disassembly, trying to understand what is inside. Okay, focusing better on the. Okay, so let's do the disassembly work. Pretty simple, just 4 screws. Let's remove the batteries, old-fashioned way, and now let's see what is inside this tiny device, which is nice. The power and frequency meter. Okay, 4 screws. 4 screws are off. Aha, I have wow, a lot of electronics. I didn't expect this. Okay, so let's see what we have here. We have a potentiometer. Probably we can calibrate the power meter. I guess that we can calibrate the power meter. A lot of other stuff. A microcontroller here. Beneath the LCD I have more parts, and the LCD. Whoa, this is a lot of stuff. Now, in order to continue the disassembly, I have to remove this screw here otherwise I can't take it out. But before taking it out, let's see if I see something. I see nothing. I have to continue opening this guy. Let's see. Aha! It is broken. There is a plastic and a screw here, and already I can show you here. I need to open, but something is broken inside. So it was probably hit by something. I don't know. I have no idea. Let's try to open this stuff. It looks like need to rotate it. Without a proper tool, this will be pretty hard to do it. Let's try. Let's try this if it will fit in. Yes, it does. Okay, so this ring is now off, and now let's see if we can remove it from the base here. There is a tiny screw here and tiny screw here. The problem is that one of them is broken already, so I don't know if I will be able to remove it. And also I'm not sure how to remove, because the LCD, maybe it is on a socket. Maybe the LCD is, by the way, this is the broken part. Maybe it is just not screws and it is not broken. Can't tell right now. Let's see if it is on a socket, because it looks like it is soldered. So how am I supposed to get it out? Wow, this is interesting. Okay, what I have in mind is that maybe I will desolder the battery stuff, but of course it can ruin the plastic, because I have one point here and one point there, and maybe it will go off. But I have this part here that it looks like I have to disassemble all this LCD to get these 4 screws beneath this part in order to take it out. I can't believe it. Ha! No, it should go out like this. Okay, it should all go out. What I have to do, just to get rid of the joints that are connected to the battery, looks like I have no better thinking at this point. I will try to do it gently without ruining the plastic. I doubt if it will work. Let's try it. By the way, I've tried to find a video about how to disassemble it, and I could not. So it looks like I'm the first that is doing this part, and yes, this goes out. Aha! Now I understand what is this, and I will explain. Aha! If you open things, you always learn new things. It's unbelievable. Okay, because we have already opened the ring, it should go out. As you can see, it is not, but it should. I'm sure it should. It should. It's not easy to do it, but it should go out. Whoa! Whoa, whoa, whoa. Everything is messed up. So I will also remove the soldering from this part, and then I will be able to take it off. The hardcore soldering is very good. And now I will explain what we are seeing here. This is of course a resistor in order to get all the power before measuring it, meaning all the power is going to this resistor. But what is missing for me is the connection of this pin to the second side of the resistor. What is the value of this resistor? This should be, I guess, 50 ohm loads for power measuring. Maybe they did another load, I don't know. Maybe the load is much lower and they are calculating the power on the load. Of course, this is 0.2 ohms because they can't allow a lot of voltage, because this might ruin this board. And this, I guess, this is the reason that it is not working, because it can't be that the other side of this resistor was disconnected from this main connection on the center. So two things I've learned. First, I shouldn't disassemble this part because it should go in even if this is assembled. And secondly, there is an issue. Maybe when they done the test on the warehouse and injecting power, they ruined the microcontroller because the center was not connected to the resistor. But I can't be sure about it. But I can be sure because if you transmit a high power, you can't expect the electronics to survive if you are not catching this power and moving the power into heat and a low voltage, and then you can measure it. And this is the way that there is just resistor that is not connected to anything. This is rubbish, it can't work. Maybe this is the reason that it is not working for me. Now about these metals, it is not broken. It should be like this. By the way, what, they put a relay here? What the fuck? Okay, there is also a relay. I don't know why do I need a relay in this device. Don't understand the relay. But now that we know how this is working, so let's try to find out. Yes, this is the minus, this is the plus. Let's try to power it like this. I will connect two wires and try to understand why the LCD is not working when it is open. So let's try it. Find the wire and solder it. So this should be the positive part and this should be the negative part. And we'll try to put direct from power supply the 5.4 volts and then check how it is going. Okay, I will solder from the bottom, it will be easier. So this is the plus, and this should be the minus. Yes, should be. Now there is an old trick. If you're not sure that you put it in the correct way, then of course you can check yourself. Okay, so best way is of course to find any capacitor and to see that the polarity is okay. So this is the plus, should be this one, and it is not. So we'll go for the minus now. The minus should be, yes, this is the minus, and the plus probably is going to DC to DC or another voltage input, but if the minus is going to the minus of the capacitor, then probably you are good to go. You can test maybe to find, I will show, you see that most of the PCB should be, I guess, ground. So if I will scratch it, yes, this is ground, so this is the correct way it should be. Now let's now put the power and see what happens. So I'm applying 4.5 volts, and I think that 400 milliampere is enough, and this will be the minus, this will be the plus, and this will be the power. And we can see that it looks okay. So why that everything is connected? I see garbage. Ha! You can't tell. And also, what are all the buttons inside that I don't get them? These are secret buttons. No way. These are secret buttons. I have no idea what they are doing. Ah, why did they put these buttons here? Wow, this is a mystery to me. And it looks that when it is out of the box, it is showing the correct numbers. Look at this. I didn't do anything. And it is just stopped. Aha. It looks like the microcontroller has a soldering issue. The microcontroller in the board. It is, look, I'm touching it, and it is powering off itself, as I've seen. Whoa, this is unbelievable. And they have a quality QC. Look, there is a QC barcode. What QC exactly did they do? Whoa, this is interesting. I am pretty excited to see how they are doing their QC quality check. The quality check is not working. Whoa. Okay. Now I need to use my microscope in order to see what about the soldering. And also I'm not sure about the middles that should be connected to the middle of the resistor. I'm not sure if it should be connected or shouldn't. I didn't see any way to understand fully 100% that it should connect it, but what other way I have just to put one side of the resist? We can't tell. Okay, let's put the microscope. Okay, so what we can see here is the Atmega 8-bit microcontroller, the most, let's say, cheap microcontroller in the world is in this stuff, and the soldering doesn't look too good to me. I will explain. I will try to show. If you will look here on this side, so you see the soldering, but it looks like the quality check did not work. You can see that the solder is not covering the top of the pad of this Atmel like you can see in this way. Here it is covered and here it is not covered. You see? The quality check is very bad. They didn't actually did what they have to do. So I will try to solder it. Now, how do we solder this? We have to use a soldering paste, and then using a regular soldering like my own, I will show what. This is a very regular soldering tip. And I will use this, of course the size looks very big, very big, much bigger than it should be, but don't worry, it can do the work. I will explain how to do it in a second. Okay, so I have this Hakko soldering paste and I will use it. What I am doing, I am just applying. I will put the paste, you will be able to see it here. What I am doing, I am just applying a very tiny amount of flux and putting it on the circuit, and then using my soldering tool in order to fix it. So let's take a screwdriver, put a tiny amount, this is enough, and we'll now get back to the board, search for our Atmel, here it is, and I'm just applying this, trying to put it a little here, this way. I think it will be enough. And now, of course, a very important thing, need to clean the tip of the soldering in order not to do any shorts or other things that you don't want to do. So now I will use the soldering and just go over it like this. And now what you can see is, of course, that each pad of the chip is covered now with solder, as it should be. And this is the problematic side, but of course if I did open it already, I will go all the other sides of the chip. So I will do exactly the same, exactly the same to the other side of this chip, putting a very tiny amount of the paste. This side it will be very easy to get with the solder to all the parts of the chip, and probably I will do a short or something, but I have no other way to fix it, so it's worth trying to do this. So again, like this using the microscope, and I will move to the other side. It will be easier to go from this side. Yes, it will be easier. I will do a focus. Now it will be easier for me. You can hear the flux getting heated. You can see all the smoke. It is a good sign. Nothing is burning. It is just doing the work that it should do. Now the last direction of the chip. Okay, I just don't know yet what about. Let's see if I need to go on other soldering part, because I can't know if everything is corrected. Also this chip is not very well soldered. What quality check are they doing? Interesting to see one day. I need to put the flux and do it for the parts, so I will do it here and on the other side. This is the best way to solve this problem. Okay, other side as well. You can see that now the soldering is above the pin of the chip. This is how it should be. Oh, also this part. Whoa, I don't have power to fix all the connection. I don't understand. What quality check are they doing? Okay, so this is exactly the last part that I'm going to do. Otherwise they have to pay me, because I'm doing on the assembly. What time? Assembly house of these guys? Maybe they did a quality check just to the sticker and not to the board. When I'm thinking about it, they did a sticker quality check. They checked that the sticker is sticked. That's what they did. Not enough flux. How do I know? Because you need to hear the creep sound and to see the smoke. This is how it should be. No smoke, no work. Okay. Now, of course, what we need to do is to clean a little bit with alcohol. But the problem is in this, that you have to use alcohol 100% and not 70%, or any other tool that will clean the PCB from debris, because alcohol 100% don't leave any watermarks that may harm the PCB and other parts around. So I'm now using 100% alcohol to clean it. Also 100% alcohol will be fade out without any other thing. It will just get will be removed automatically clean it a little bit, what I can. Okay. Okay. Hopefully now it will work. So I'm curious as you at home. So let's test it. We'll put the camera back. Okay, so my guess is the relay is ringing and it will continue to ring till I will connect this wire. And yes, it is stopping. Let's remove the wire and touch the power. Let's run it. Doesn't look like it is. Okay. You hear the relay. Now we will put I don't know about the relay and I don't understand the relay stuff. Why the relay rings like this? Aha! Maybe it should all connected to ground and then it will be all okay. Okay. Now it's time to close everything back and see if it is working. I will close everything and try to activate, but I still don't understand if I need to connect this wire here to here because I didn't see how to do it because they didn't. It looks to me like it should be connected. 100 micro ohm. Why did they put this resistor? Why did they put it? A big question. Okay, let's try to close it and recheck. Okay, so eventually the LCD is fixed. But the relay that is measuring the power, something is wrong with the power measurement that's causing the relay to switch on and off all the time. So need to take it again apart. I don't know if I will do it, maybe later.